You know that weird feeling when you go to pick up a huge, empty box and it's shockingly light? Or maybe you've grabbed a tiny little rock that felt way heavier than it looked. Well, today we're going to bust that big myth that big always means heavy.
So, let's just get right to it. I've got a question for you. Which is heavier, a giant beach ball or a small rock? I mean, your eyes are telling you one thing, right? The ball is way bigger. But your gut is probably screaming that the rock is heavier. So what's really going on here? Let's dive in and figure it out.
Okay, so we are about to totally expose this big and heavy myth. The whole reason size can be so deceiving is because of two key scientific clues that work together. And we're going to start with clue number 1.
So, our first clue, it's all about how we measure space. And this brings us to a word you've probably heard a million times, maybe in science class, volume.
So, what is volume exactly? Well, scientifically speaking, it's just the amount of space an object takes up. That's it. You can almost think of it as its footprint in our 3D world.
Or, an even simpler way to put it is to just ask yourself, how much room does it fill? That's all volume is. And notice it has absolutely nothing to do with weight. It's just about size.
Think about this. It's a perfect example. A big, empty cardboard box has a huge volume, right? It takes up a ton of space. But we all know you can pick it up with one hand. It's super light. So clearly, volume alone is not telling us the whole story here.
All right, on to our second clue. To really solve this puzzle, we need to know how packed something is. And for that, we have to bring in another concept. We need to talk about density.
So, what in the world is density? It's simply how tightly packed the matter, the actual stuff, is inside a certain amount of space. This is the missing piece of the puzzle. This is what connects an object's size to its weight.
Okay, check this out. It's a great way to picture it. Imagine you have two boxes, both the exact same size. So they have the same volume, right? Now, you fill one up with feathers and you fill the other one up with sand. Which one is going to be heavier? The box of sand, obviously. And why? Because that sand is just so much more densely packed than all those light, fluffy feathers.
And hey, there's actually a super simple recipe for figuring this out. First, you need its mass. That's just a fancy word for how much stuff is in it. Then you get its volume, which we already know is just the space it takes up. And then you just divide the mass by the volume. Boom, that's its density.
All right, we've got our clues now. We have volume and we have density. So, it's time. Let's finally crack the case of the beach ball versus the rock.
And here it is. This is the big aha moment. The beach ball, it has a high volume. It's huge, but it has a super low density because what's inside? Mostly air. Now the rock, it has a low volume. It's tiny, but it has a really high density. All its matter is packed in tight. And that's the whole secret. The super packed rock is heavier, even though it's way, way smaller.
So let's just recap real quick. Volume is all about the space an object takes up. Bigger object, more volume. Simple. But density, that's about how packed that space is. And that means even a really small object can have a ton of stuff crammed into it, making it incredibly dense.
This isn't just some fun little brain teaser. It has real-world consequences. Let's look at one of the most common places you can see density in action every day, trying to figure out if something's going to sink or float.
And the rule here is just so simple. It's all about comparing an object's density to the density of water. If the object is less dense than the water, it's going to float. If it's more dense than the water, well, down it goes.
And that's exactly why a log floats, right? Wood is full of tiny air pockets, so it's less dense than water. But that same little rock we've been talking about, it's super dense, so it sinks straight to the bottom. It's the same exact principle, just in a different situation.
Okay, we've gone through a lot here. So if you're going to remember just one single thing from all of this, please make it this next part. Here you go. Just burn this into your brain. Volume is how big. Density is how heavy for its size. That's it. It's so simple, but it perfectly nails the difference. So from now on, when you pick something up and think, wow, this is heavy for its size, you'll know you're actually talking about its density.
So, I want to leave you with a little challenge. Go ahead, take a look around you right now. Based on everything we just talked about, what do you think is the densest thing in your room? Give it some thought. The answer might actually surprise you.